We're still in Chapter 2. We're in Section 2.2, solving equations using the multiplication principle. So we're going to do where we did addition and subtraction previously. Now we're going to do multiplication. So for any real numbers A and B with C not equal to 0, A and B is equivalent to A times C and B times C. Again, that screen that slide where we're looking at it, whatever you do to the left side, we do to the right side. We're multiplying both sides by 6. So here's an example. Now let's think about this. What operation is going on right now with this 6x? Do y'all remember? It's 6 times x. Remember, mathematicians are lazy. So to undo multiplication, you divide. So whatever you do to the left side, you have to do to the right side. So that gives us really 1x, or just x, and then 96 divided by 6 is 16. Now if we go back and check our work, we're going to plug in. So we get 96 equals 96. So this is true. So 16 is our solution. Now this one is negative 7x. So whenever you divide both sides, you divide by the coefficient and the sign. So in this case it's negative 7. So we're going to divide both sides by negative 7. And what happens is these negatives go away, the 7 goes away, just leaving an x. So now you have 84 divided by negative 7. That's going to give us a negative 12. So when we get ready to check our work, if we say negative 7 times negative 12 equals 84, remember, a negative times a negative gives us a positive, and then 7 times 12 is 84, so our answer checks. So negative 12 is our solution. Now a lot of times you will just see this as a negative with an understood. It's understood that there's a 1 here. A lot of times if it's positive, we just leave that 1 off. It's not a big deal. But you can't have a negative variable as part of your solution. So in order to get rid of that, you're going to divide both sides by negative 1. And when you do, that makes this x become positive, and that 6 is now a negative 6. And so that works. And then you can go back in and you can double check that. If you say negative 1 times negative 6 equals positive 6, negative times a negative gives us a positive, 1 times 6 gives us 6, so it does check. So just be very cautious of that. They like to throw those at you. There are many ways to do this problem, but the simplest one is when you have a fraction, you can multiply both sides by the reciprocal. Think about it. If I said 3/4 times its reciprocal, which is 4 over 3, that gives me 12 over 12, which is simply just 1 over 1, or 1. So that's the whole goal. We're trying to get that variable by itself, or to be like 1x or 1y, whatever the variable is. So if we go through and we multiply both sides by the reciprocal, remember you got to drop a 1 up under here, then we can start doing a little bit of cleanup and see what we can come up with, okay? So these are going to go away, so that leaves us an x. If you don't remember your rules about multiplication of fractions, you need to go back and review that. But 3 goes into 3 one time, 3 goes into 15 5 times, and then 5 times 4 gives us 20. And you can still go back and check your work. Think about it. If I say 3/4 times 20 over 1 equals 15, 4 goes into 4 one time, 4 goes into 20 5 times. You multiply here, you get 15 equals 15. So this is true. Again, you guys should be able to check your work, and it should work out every single time. Now the next problem we have is dealing with decimals, and you can still divide by decimals. You can either do it longhand or you can use your calculator. Since this class is allowed a calculator, I would use the calculator. 3.2 times y equals 9,600. If we divide both sides by 3.2, y now simply going to equal, you punch that into your calculator, 9,600 divided by 3.2, and you get 3,000. And again, you can check it. 3.2 times 3,000. You plug that into your calculator. You're going to get 9,600 equals 9,600. So it's true. So y is our solution. Again, I will assign practice problems in class for us to do.